हेलो ऑल, गुड मॉर्निंग। क्या आप लोगों को मेरी आवाज़ जा रही है कहीं से? तो थोड़ा बहुत। चैट इज़ द ओनली सोर्स जहाँ से हम लोग स्टार्ट कर सकते हैं। ऑडिबल हूँ? कुछ तो चैट में बता दो। ओके, तो विल स्टार्ट। जहाँ प्रॉब्लम आए लेट मी नो, मैं स्टॉप करूँगा और फिर विल री गो थ्रू दैट पर्टिकुलर सेक्शन। स्टार्ट करने से पहले आई एम सॉरी कि सबका नींद सुबह सुबह ख़राब किया मैंने। दूसरा कोई ऑप्शन नहीं था आज। चलो विल स्टार्ट। द मोस्ट इम्पॉर्टेंट, आई थिंक 7 लोग हैं। चाय हर्षित भाई ने बनाई है, तो अपना तो कुछ रोल नहीं है उसमें, मैं बस सेटअप करने में लगा था। तो इफ़ यू सी, फर्स्ट थिंग फर्स्ट, जो ये टॉपिक है ये सबसे ज़्यादा इम्पोर्टेंट टॉपिक है पूरे एरेज चैप्टर का, ठीक है। अच्छा, डीएसए का एक ख़ास बात पता है क्या सबको? जो इंटरमीडिएट में जो लोग शुरू करते हैं ना डीएसए, वो एरेज पे शुरू करते हैं और एरेज में ही ख़त्म करते हैं हमेशा। मतलब मेरे साथ भी बहुत बार ये हुआ है, और मैंने बहुत किसी से ये कंप्लेंट सुनी भी है कि दिल स्टार्ट ऑन एरेज एंड दिल फिनिश ऑन एरेज, वो आगे बढ़ ही नहीं पाते हैं। ऐसा हम लोग होप करते हैं कि नहीं करेंगे। और तो कुछ नहीं। एरेज सबसे इम्पोर्टेंट कॉन्सेप्ट है और सबसे टफ भी कह सकते हैं। अगर क्वेश्चंस क्लिक कर गए, पैटर्न समझ में आ गया तो वी कैन डू इट। अगर पैटर्न समझ में नहीं आता है तो फिर इट्स वर्थलेस, जस्ट एज सिंपल एज इट इज़। तो लेट्स बिगिन। देखो, एरेज तो सबको पता है कि जीरो बेस्ड इंडेक्सिंग होती है उनमें। तो ये 5 लेंथ का हमारा एक एरे है जो कि कुछ ऐसा दिखता है। अब सब एरे का डेफिनेशन तो आई थिंक सबको पता होगा, सबको पता होगा, कुछ नहीं है, सब है और फिर एरेज है ना। सब एरेज का डेफिनेशन सबको पता है। एनीवन हु कैन जस्ट लेट मी नो कि सब एरेज, सारे सब एरेज कोई लिख सकता है क्या पूरे क्लास में? सारे सब एरेज अगर प्रिंट करने हुए तो सारे, और कितना टाइम वो लेगा अगर सारे सब एरेज प्रिंट करने हुए तो उसको? I know I'm bit slow, but bear with me. क्लास के एंड तक में बहुत मज़ा आएगा। कोई किसी का रिप्लाई नहीं है मुझे। आई होप कि सब लिख लेंगे। अगर हम समझें, मेरे पास एक एरे गिवन है जो कि 6 लेंथ का है। ऐसा है कि 7, 12, 2, 6, 9, -1 है ना। तो एक मैंने एरे लिया है 0, 1, 2, 3, 4, 5, that is of length 6, and if you closely observe, there is one negative element too, just for the sake that we are covering everything. So let's think of writing subarrays. Okay, so you know, subarray starting from index 0. So if we see how many subarray can start from index 0. So from 0 to 5 it can go 1. From 0 to 4 one more subarray, right? From 0 to 3 one more subarray can be done. 0 to 2 one more subarray. 0 to 1 one more subarray. And 0 to 0 itself is one more subarray. Okay, so if you closely observe over here, there are uh, 1 2 3 4 5 6 arrays possible, right? And 6 is our n over here. In this case there are 6 element in this particular array, right? So what we can conclude from here, just one second. What we can conclude from here, that we can conclude that from ith index, that is the starting index, if I is equals to 0, n subarray is possible, right? And if we see, if we again do the same thing over here, if we do the same thing over here, how many subarrays from index 1 will be possible? 1 to 5, 1 to 4, 1 to 3, 1 to 2, 1 to 1. So total n minus 1 subarray is possible from index 1. So what we can say from here is that how many subarray in array of length n is possible? N plus n minus 1 plus n minus 2 plus n minus 3 up to 1. Is this statement making sense for you guys? How many subarrays we can make? So actually I didn't give the proper definition of subarray, and I don't feel that I should give the definition for the same. Uh, is this statement making sense to you guys, that how many subarrays possible? So can we clearly say that okay, uh, total number of sub arrays in an array of length n. Okay, so this can also be written as n into n plus 1 by 2, just basic sum of APs, right? So is this complete sum of number of the sub arrays possible for length n making sense to you guys? Okay, okay. So keep interacting through chats only. There is no other source. So if you closely observe, there are two things. There are completely two things in DSA. The first is visualization. If you are able to visualize anything in DSA, like if you are able to visualize, okay, so in arrays, how we can see in arrays, okay. So if there is a question with sub array, how you will be visualizing that? Okay, first from index 0 to n, then from index 1 to n, then from index 2 to n. Then these kind of like visualizations will help you later in the later part, while you are solving questions, while you are recognizing some kind of patterns in the questions. So the most important part which I have observed over my journey is visualizing visualizing whatever it is there in the question. If you are not able to visualize, you won't be able to solve. You just have to first visualize, look how question is propagating, and then accordingly you have to make your logic working. You don't so first thing first, if ever in DSA you are not confident in writing the logic on a piece of a paper and a pen, then don't code in compiler. It won't make any sense until you are confident that okay, this piece of code will work, then only go to compiler. Else it's just myth that the code will get solved, okay, that the code will work over there in the compiler. First, every time, first take a pen and paper, write the logic, then again come back and code in compiler. There will be some certain complications with the syntax and all. It's okay, it's fine. Every developer goes through the same. Other than Mahima, just because Mahima is having good logical skills, he will remember everything, whatever it is. So I will, most of the time I'll forget whatever syntax it is there, like what priority queue syntax says. So I need to keep a track that okay, priority queues syntax will be written like this. This is just my, what we say, drawback, not drawback. I'm not getting the word exactly. Aniket says if we are shuffling the position, if we are not shuffling the position, okay. Okay, just list. Sorry, I was not reading the chat. Okay, Dinzo 2, I don't know who it is. Why not possible of Subarray 12 7? They are they are different elements. Why not possible Subarray 12 7? Okay. Correct question. Correct question. So I'll get back to on this just right now. If you are not supplying the position, right? Which positions are you asking? What is the answer for my above question? Samkit. Okay. So Samkit, there is something called subsequence and subarrays. They both are different thing. Okay. So what happens in subsequence? If it is, if we are having the same array, I'll copy paste the array. Then we'll discuss about the same. Okay. So uh, I'll tell you. Just a couple of seconds. Okay. I'll tell you. Mm, Okay, I'll tell you. So for subsequence we can write one of the subsequence I will write. You can take anything in the sequence, or you can omit whatever you want. From 7 is a subsequence, and 7 comma 2 is also a subsequence. 7 comma 2 6 is also a subsequence. 7 comma 2 6 minus 1 is a subsequence. So anything which comes in the sequence, either you take or you don't take it, it will be a subsequence. That is a different part. But your question is, why not possible subarray 12 comma 7? They are different element. So 12 comma 7 is not possible in subarray. 7 comma 12 is possible. Just in case, uh, I'm not getting exactly different element. Can you frame your question, or can you try to ask in a different manner? I'm not getting it. In what context you are asking, or so can you re-ask it with some different uh, context? Maybe I'll get it. Okay. So what we learned is that visualization, that how we can calculate the subarrays. Visualization defines subarray. Okay. Regarding permutation and combination. Okay. So we'll get back to all the things. So define subarray, then it may be, then it will clear maybe. Okay. So basically what we can say, that sub array is the smaller part or smaller version of an array. Not version, we can say, I didn't have memorized, continuous version, we can say, smaller continuous. Everything should be in a continuous manner. If you are taking 0, and you should have, you must have to take 1 in if you have to take 2. Okay, so this is foundation for sub array. But just for the subsequence, if you are taking 0, you don't have any foundation to take 1 first index. You can directly take second index. This is subsequence. So subsequence will study. So this is also one of the most important topic. We'll study post arrays later part, in the later part of this particular course. So I hope I'm clear about subarrays. And about permutation and combination, we'll discuss later. I have a couple of questions which we'll discuss in for permutation and combinations. Okay, so if we move ahead, uh, just starting from a basic question, that just a very basic question, with a code, maybe with a code we can go. So question, which question we were on the last? Okay, so didn't mention the question number. Okay, so over here we were A6. I think it's 10th, because there are three questions in between. So question number arith 10th. If we are given an array like basic array 1, 7, 9, 12, 5. Okay, this is our array. Just print all the sub arrays. Can you let me know who all can print it now, with the given logic which I have taught over here? Who all can print it? Samkit, maybe we can discuss this after the class. Can you please hold that out? For I equals to 1, 12 comma 7 while going ahead. Meanwhile, you guys can ping who all can print this, or print all the sub arrays over here, or I'll write the code for the same. Okay, I might be. Okay, just hold this doubt. I'm not going in this manner. I'm always going in. Sorry, I'm not going in this manner. I'm this manner. I'm going in this manner only. I think that you can optimize. Maybe I'll optimize. I'll definitely optimize. I'm just asking who all can write the first basic code for printing all the sub-arrays. The first question is print all the sub-arrays. Who all can write this? Beat any time complexity. Come on, guys, quickly. We need to jump to a lot of questions today. N square. Okay. Okay. You can write this in n square, Mahima. Please tell me the time complexity too. Actually, I'm not teaching you guys that how to write the brute force logic. N square was okay. 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 Then very good. Anyone else? Okay, Samkit in n square. Paras in n square. Achal also in n square. Anyone else? Aniket Joshi, 2 minutes. Okay. So now we'll write the brute force. First, I'll write the brute force quickly. So for I0 to n minus 1, okay, for j starting from I till n minus 1, and for k starting from I till j, we can print all the numbers and that number will be subarray. So this will take order of n cube time complexity, but we can further optimize it. We can optimize from here only. We'll start printing in the second loop only. So this will give you order of n square time complexity, and you will bare minimum need order of n square time complexity in order to write all the subarrays. That is the best case you can ever have. So this is all about subarrays. You won't get that much question in subarray. You will get a different type of question. It is called contribution sum technique. You will get contribution sum technique over here. Just 1 second, sorry. uh, you will get contribution sum technique over here, but just okay. So you will get contribution sum technique over here. uh, uh, how come? So just directly I conclude, sorry, I'll delete it. How So there is only one to two types of question directly on surveys if you go on sums and different patterns. But the most important pattern we should recognize in subarray is sliding window. I'll I'll just go with it. In the later part of the class, we'll start with the questions. I'm just trying to teach all the theories, whatever is there in my mind, and then maybe we can continue with questions either today or like in the next class. Until then, I'll teach all the theories, because uh, with the fresh start in the morning, we can learn all the theories, whatever it is there, so that we can visualize it later. Sliding window. Sliding window. Have you guys ever seen a sliding window? Basically, it's there in my room only, but I can't show you. So there is a window, proper window, and there is one window which is moving. So it's the window empty space, and there is one window which moves during this course of particular uh, window's empty space. So this is our actual window which is moving, and this is the empty space of the window. We can move this window from here to something like this. It will keep on rotating, keep on moving from this area to this area. Okay, so it's the same name and the same concept. So in sliding window question, how we'll recognize that okay the window is particularly sliding, or mm, actually I might have started teaching you this concept with a question, but I know that you all guys are pretty much aware about array, so I didn't started the same with the question. I just started with uh, teaching you the concept of it. Okay, so how you will recognize that okay it's a sliding window question. Okay, so in anything will be given, it is either arrays in the question or strings. Any one of it might be given. Okay, and then they might be talking about something. mm, mm, they might be talking about some part of it, not a whole part. Okay, the whole part might be there. I agree that okay, in sliding window, if we assume the size is completely of the window size, that is the whole part. I agree this can be also possible, but In the major questions they might be talking about some part of it. Okay, if we say array of 1 2 and 3, okay, so they might be talking about either one element or two element, or in worst cases they might also talk about three elements over here. Okay, so some part of it they might be talking about, not complete part. And there must be given another variable, that is k. Okay, I should not name is variable over here because it might confuse you in the later part of the theorem, whatever we say. There might be given one extra digit or number, that is k. Okay, and k might be the size of window. Okay, that they might say, okay, find the sub array of size k which gives you maximum minimum sum, something like that. Okay, we can also say they might deal with some kind of max or min. So this is one part of sliding window. What all will be given, I'll repeat it. Arrays or string will be given, they might be talking some part of it. They might have given you a variable k of, that k must be representing that particular size. In first case it might be representing size, that okay, or size. If we have array of size 7, if we have array of if we have array of size 7, so they might be giving us array of they might be giving of the size 3. Okay, so this is one part of it, that okay, size 7, and then you should calculate the maximum sum of a sub array having size 3. So that is the part of a sliding window. This is how we can recognize, okay, sliding window is getting observed over here or not. Or the k can also be a number. I'll tell you, a number which says, okay, so of some 7. So over here this is called fixed size. Over here this k can also be a number like they can say of some 7. That is also a sliding window pattern. I'll teach you that how some 7. If we go next, so closely observe over here that two parts of sliding window is there. The one is window. We are discussing based on window size. If window size is fixed or window size is variable. If window size is fixed, they will give us a fixed size. Or if window size is variable, they will give us an extra constant. Something will be fixed over there. Something will be fixed over there. Something else will be fixed over there. Like they can give you extra sum. Okay, they will give you like maybe I'm recalling some as of now, or anything it can be given. But they will be talking about two or three things. First, it might be array or strings. Second, they might be asking you something max, something min. And third, that okay, uh, if it is a fixed size sliding window, they must have given you some kind of k which represents the size of that particular window. Or if it is like not fixed, it's variable size window. Then in variable size window, what happens exactly, what happens that okay, uh, window size can vary, and that particular concept, like suppose 7 is the sum over here. So from here to here it is 7, and then once again if you move from here, if it is 7 over here, the window size will get 1. Over here the window size was 3, just in example. So just an example, this can vary. Over here window size is varying, but the sum remains constant. So these two types are of their in sliding window pattern. I hope I'm clear. Let me know if I'm clear, then I'll move ahead with the questions. There are two types of sliding window. First is fixed size window, the second is variable size window. If it is variable, then there must be something which is fixed over there. So we need to recognize the pattern like this, and they might be asking something max, something min, something like that. So let me know if I am clear or if I need to reiterate. I tried my best possible, slowest possible version to reiterate. Okay, a couple of more yeses, guys. Okay, Aniket and Mahima are comfortable with this speed. Who else is there, guys? Are you guys comfortable? Ah, yes. On a couple of more yeses with there in chat. Okay, so we'll first start with uh, the basic size of sliding window. Post this lecture, I'll give you more than 10 to 12 questions to try. Not 10, approximately more than 7 to 8 at least, to give it a try, to understand that okay, if you are able to catch that okay, this particular problem is of type sliding window. Okay, so we'll start with the first question. The the first question of this sliding window is array 11th, and we can say we are given a size 3. The size is prefix defined. We need to find the maximum sub array sum. Okay, tell me, guys. So this is the sub array given. This is the array given. I'm sorry. This is the array given, and we need to find the maximum sub array sum of size 3. Okay, so I'll first write on this particular example, and then we can move ahead, and we can check that okay, if it is possible to write sub array sum. First of all, okay, so just remember, guys, just remember that in order to start the subarray sum or sliding window, whatever, if the size is fixed, just calculate the size, just calculate that particular sum in a separate for loop or whatever loop you can use. I0 to I less than 3, that size, and I plus plus. So store it in a sum. So what will be this? -4 -5 -9 plus 3 is -6. Okay, I'll take a different pointer from here. So that is -6, and if this sum is store this sum in max sum 2, that is -6, because we have this is the only sum which is maximum over here. Now we have done this first part first, we have done this. Okay, we have done this, the very basic part. Is this part clear to you, that okay, they have given the window of size 3? So what I have done is that I will calculate that particular, I will go in the first window that is possible from index 0, and will calculate the whatever requirement they are asking. Uh, they are asking for maximum sum, so I have calculated that maximum sum over there. And then we'll keep on moving like sliding window. So the sum was -6 from index 0 to 2. Let's go from index 1 to 3. Okay, so while going from index 1 to 3, you closely observe one thing, that uh, we are omitting 3 from the sum and we are adding 2 to it, right? Right. So what we'll do is that we'll do subtract 3 from here and we'll add 2. So this will be 6 minus 3 is 9, minus 9 plus 2, that is 7, minus 7. Okay, so just I have calculated it. I'll write. So from index 1 to 3 we are getting -7, right? We are getting -7, right? Again, if we move a little ahead, so if I move my window from, so suppose this is my window, so this is my window. Sorry, suppose this was my window at first. This was my window at first. I moved it here to calculate the sum of this. Then I can also then it will again move from here to here, these three sides, that is 2 comma 4, right? That is 2 comma 4, and the sum of it will be -7 -4, and what we'll do, we'll add 1, that is 10, right? -10. So -10 will be sum of these three indexes. What we did, we did subtract this and we did add this. If we again move from here to here, then from here to here, then from here to here, and we'll keep on comparing with -6. If my sum ends up to -6, if my sum ends greater than -6, we'll store that sum in that particular maximum sum variable, and we'll keep on moving our counter till our can you guys let me know that, okay, till what arrayth position I will write the for loop? What will be the last position of my I, so that my index is not going to be out of bound? Maima, can you let me know which index should I write over here? Generic. I don't want that. Okay, over here you should write 9. I don't want this. I want a generic size -3. Not size -3. It's array dot length, that is 12. -1 will give you 11. So array dot length -1 is our index minus size, right? So up to till this size we have to move our window and check, okay, that if we are getting a better sum than max sum, then we'll store it, or else we'll discard it. Okay. Okay, so is this particular approach, guys, clear to you? Over here what we have done, over here what we have done, over here what we have done, so we have moved, right? We have moved our window from 0th index to 9th index, and we kept on checking that, okay, is there any sum which is greater than -6, and then we have stored that particular sum and it's done. Boom. Is this particular approach clear to you guys? This was the first example where the window size was fixed. Okay, let's move to other example. Okay, I'll tell you guys the very other example of this particular question, and then we'll sorry, my bad. Okay, so this was a type of question. It was named as array 11. We'll go to array 12. Okay. Okay, just my is asking len minus size or len minus 1 minus size. Okay, let's recalculate. Len minus 1 is 12, minus 1 is 11, minus 3 is 8. No, sorry, len minus size will be direct answer. We need to go to till, I'm sorry guys, I'm sorry, I have not memorized everything. Okay, it's just coming out of flow. Whatever I know, I'm just teaching you. I'm not memorizing anything. So it's direct. It will be directly. I'm extremely sorry for the. Uh, that is n minus size. N represents length of the array. It will go. It should go till 9 because there are 3 elements in the last, and 12 minus 3 is 9. It should go till there. Okay, I'm sorry guys. So please re-update your whatever if you are writing something. So if you go to array 12, if you go to array 12th question, I'll just paste. Okay, so we are aware of this question, right? So if I update this question like this, just a couple of seconds, boys. So this is our question, right? If I update my question like this, I'll write my question. Just give me 1 second. So find the max length of subarray which holds the sum as 10. Okay, will go. Okay, Aniket, I have one question. Aren't we going to the last element? No, Aniket. Okay, if you see, if we if you see, we will be going to the last. We'll be going to the last element. You are correct, but my question is till up to what? Yes, you both guys are correct in some order. You both guys are having a different approach to this particular question. You both guys are correct. Just 1 second. Like when we need to remove 9 and add 5. Yes, you both guys are correct in some order. So Mahima is thinking from the start, she is taking, and you are thinking the area like in this approach which I taught. It is like from here, not here exactly. From here you are thinking that okay, I'll start from the next index with the size index, and I'll keep on subtracting this thing. So मेलोडी खाओ और खुद जान जाओ. I'm not giving you, I'm not feeding you with my spoon, whatever it is. You just go, I taught you the concept, you just go write everything, try to optimize. This is how the concept works, and you'll come to know that okay, that it's going till where. But uh, you can write in both the manner, that is possible. Just relax and try doing the code by your own. I'm not writing the code. I'll write the code of sub array in the sub array, or the whatever we say, whatever the concept which I am teaching today. I'll write the code for the same, or the toughest question which I found in the this particular concept. I'll code it in the next session. So till that point of time, let's hold on. Just digest all the concepts which I'm teaching, and then later part we can also deal with the code in the next session. Okay, till that point, relax. We'll code na? We'll code the best questions whatever I feel for the sub arrays or sliding window. Okay, handle our own edge cases. Yes, yes, you can handle your own edge cases. You should be capable of handling your own edge cases, because if I'm spoon feeding you everything, then in the interview you might be able to solve only these particular questions, not the questions which you are getting right. Okay, so you should be capable enough to handle your own cases. So are you guys sure with this particular question? Are you guys clear with this particular question? Let's jump on to our question. Let's not waste our time. Find max length of subarray which holds the sum as 10. Just read this, guys, and let me know if you are getting the edge, that okay, over here we are using variable sliding window, because the constant which is fixed is sum as 10. Okay, keep on uh, one of my closest friend once told me that we should keep observing the questions until I found the solution, until we found the solution. So observe it and let me know if you are able to recognize that okay, we are using sliding window over here. So let me know who is able to recognize that okay, there is a sliding window in this particular question. Who all? I think अरे बताओ गाइस कौन कौन है जिसको समझ में हु इज आई एम सॉरी. Let me know if you are able to guess. Okay, so enough time spent. I'll directly jump on to visualize you that okay, there is a sliding window over here. Okay, we'll start first thing first. Just follow whatever I'm teaching. Be relaxed and follow. Don't think, don't overthink, just follow whatever I'm teaching. Okay, so I'll start with this index, not getting an intuition of sliding window. Yes, that's where you are stuck. That's where you're stuck. Okay, yes, correct, good question. That if you're not, it's very good that if you are not getting the intuition of sliding window over here. Anyone else? Guys, come on, quickly write if you are able to observe that okay, over here there's a variable sliding window. Aniket, Samket, anyone? Plus one. Okay, nobody is getting the intuition. Okay, okay, very good. So uh, actually I should not have taught you this question today only, but no problem. Okay, we'll go one by one. Okay, so before we go over here, uh, we'll 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 observe a couple of things. Okay, and then uh, and then we'll carry on to sliding window. So just in a hypothetical case, just assume one thing. Okay, in a hypothetical case, just assume one thing. If we have a sum, if we are given that we need to write a sum of 10, just in this example, if one of my pointer is over here on 4, so is 10 greater than 4? No. So we need add something to it, right? We'll again move will again move. Okay, that again. Okay, I'll what I can do is that I can omit, just for an example, I can omit minus negative elements just to teach you uh, in a fresh manner. It can also be done with negative element, don't worry. So I'll write just the same example over here. If, let me check if we are getting 10 over here. No, we are not getting 10, we are getting 8 over here. Okay, so I'll copy this example. So in order to get 8, 4 and 3 is here. Okay, I don't know why my pen is 4. We will go to first number 4. 10 is there. Is 10 is, sorry, 8 is there. 8 is there. My bad. 8. Okay. 4 is I will point our first index with start, and will point our end index. Now start and end is both on this first index, that is 0 1 2 3 4 5 6. Hana? So if we need 8, is 4 greater than 8? No. So we need to add something more to it. How we can add something more? We'll move our end pointer from here to the next element. That will give you the sum of, end will move and we'll calculate the sum. The sum will be 4 plus 3 is 7. It's still less than 8. We'll again move the counter will say that okay, I have moved the end counter. The end counter now will say 7 plus 5 is 12, which is less than 8, which is less than 8. Okay, okay. So now if we see, if the sum is greater than, if the sum is greater than asked sum, that is if the current sum is greater than sum, current sum is greater, we'll move the start pointer. So if we move the start pointer from here to here, we can closely observe we are subtracting 12 minus 4. We are subtracting this total sum was 12 in this window, and we are subtracting this sum. Okay, this sum now would become 8, and this is our 8. So we'll check, okay, what is the size of window? What is the size of window over here? E minus s plus 1. How this comes, I am telling you. Just remember that. Okay, we can calculate a minus b plus, sorry, b minus a plus 1 for closed interval of a and b. I'll teach how this will come. Just remember e minus s plus 1, that is 2 minus 1 plus 1, that will be 3 minus 1, that will be 2. So the length, maximum length which I am getting for 8 is 2. Okay, one iteration done, we got the maximum length as 2. We'll again move, one iteration done, we'll again move with this. Now I'm sorry guys, they need to optimize their software. I'm not touching it. I will move from index 2 to 3. Again, if you will check 6, we'll add 8 plus 6. 8 is constant over here, not constant for these two indexes. 8 was there, we'll add 6, that is 14. Still it is greater than 8. So what we'll do, if the current sum is greater, we'll move the start index. The start index will move from here to here. Then we'll subtract 3. If we subtract 3 from it, 14 minus 3 will give you 11, right? 14 minus 3 will give you 11. 11 is still greater than 8. We'll again move the start index. The start index will now go on to third index. This will be now r start. So we'll subtract 5. Now 11 minus 5 will give you 11 minus 5 will give you 6. Okay, so will if you see 6 is less than 8, 6 is less than 8, so what we'll do, we'll move our end pointer again. So if sum is less than, if the sum is less than if the current sum is less than, there are two things which we are doing over here. I'll write it just quickly. If current sum is less than sum, what we'll do, we'll move the end pointer plus plus. If the current sum is greater than sum, we'll move our start pointer, and we'll keep the start and end pointer in the beginning in order to start this algorithm. Not algorithm, this is particularly a different version of sliding window. So what we are doing, we are actually, okay, I'll complete it. So I won't complete it, you do the dry run by yourself. So this is the main funda which we are doing. If the sum is greater than, the sum is if the current sum is smaller than sum, will need more element, right? Just imagine, if I need 8, and if our current sum says okay we are 5, what we can do, just given if we are having positive numbers, so what we can do, we can expand our limits. The limit will get expanded, we'll need more element to make the sum as 8. We'll expand our limit from 5 to 8, right? We can go till one more, we can move our one more ending index. Okay, the ending index can be anything. We moved our ending index, and that gave us some more value. It might be 5 plus 1 6. So we'll move our ending index. But if we know that okay now our sum becomes more than 8, what we can do, we can subtract something. So subtracting something, we can lose one index, we can lose one index. We can make our window size smaller. Over here we are making in the first case, when the current sum is less than the required sum, we'll making our window size bigger. In the first case, where our current sum, over here we are making our window size bigger, and over here we are making the window size as smaller. So actually if we closely observe now, we are actually moving a window, we are actually moving a window of variable size till my size reaches 8. Will it might be possible that we'll get some more element over here which says 2 plus 2 plus 2 plus 2. Just for an example, if we see in the end, if we are getting somewhere 2 plus 2 plus 2 plus 2, okay, and we over here it was 11. So just imagine this case, hypothetical situation. I'm not spoon feeding you, I'm just telling you one thing. If our start and end index, suppose this is our array, okay, and suppose this is our array, and this part is already there. So this particular part, my bad, so this particular part is before it, and this is our array. Now this is our array. So somehow start and end pointer will come over here. This is, I am pretty sure, just because uh, it will try to shrink its size in order to make that particular sum 8, because 11 is greater than 8. So it will keep on trying to increase the reduce the size. So over here you will find edge case. Where are you guys asking anything? How we need, you are using sliding window here just from the question. Okay, I'll teach you now. I'll teach you the patterns, whatever I told you now. Okay. So Maima is having a very good question. How do we know that we need to use sliding window here just from the question? Okay, very good question. That what I told you, just focus on this. Okay, I'll quickly go back to question once more. Okay, so I told you they might have given you arrays or string. Okay, here array is given, they might be asking some part of it. They are saying find me the sub array which is having the maximum length in order to get the sum 8. Okay, then I also taught you the window can be of size, the window size can be variable. So something else will be fixed over there. So what is fixed over here? You know, what is fixed over here? Can you tell me, Mahima? What is fixed over here? I know the stream is bit late. You will get a couple of seconds in order to respond to it. Can anyone let me know that, okay, M largest sub-array length asked है, right? Then why are we trying to shrink the, why are we, because in this particular question there is no negative element. If the sum goes more than 8, we need to shrink our array. Question repeat. Question repeat. Okay. क्वेश्चन है M, क्वेश्चन है, क्वेश्चन में लार्जेस्ट सब एरे लेंथ रिक्वायर्ड है, राइट? यस. देन व्हाई आर वी shrinking the window in okay Mahima, so we are shrinking our window to get this, to get, which is what is fixed over here in this question. Can anyone tell me what is fixed? What is the only thing which is fixed in the question? First I'll answer the first question, then I'll go back to second question. Anyone? क्या fixed this question? What is fixed in this particular question? हाँ, it will be given for this time. Just imagine it will be given, right? I'm not able to see anyone, any other than yours chat. Is it my glitch or somebody else is not responding to my question? Sum, yes, correct. Sum is fixed. Sum is fixed. Sum is fixed. So they are asking for the size. Okay, they are asking for the size and sum is fixed in this particular question. Yes or no? Yes. Okay. So over here in the first question, what was fixed? Length was fixed and they were asking for maximum sum, right? I just reciprocated the question. Can you observe it closely over here? They were asking max subarray sum of size 3. Yes or no? They were asking for max subarray sum. They were saying that okay, size is fixed over here and we need to give the maximum sum whatever it can be. So they were asking maximum sum with the size 3. Over here what they are asking? Over here they are asking sum is fixed and what is the maximum size of the subarray possible. I just tried to give you the best example which I can. There are n number of examples present. I can teach you in the next class too. But over here they were asking for maximum sum of size 3 and over here they are asking for maximum length, maximum subarray length of something k, whatever it is. Sum is fixed over here. So is my analogy clear? That your first question, that how we come to know that okay, we are gonna use sliding window just from the question. Is my analogy clear? Can you let me know once in the chat if it is clear to you? That okay, I'm not teaching you that okay, I'm not teaching that okay, this the question is solved. I'm not saying that. I'm just saying, is the analogy clear that okay, we might end up using sliding window in this particular question? Yes or no, guys? Yes or no? Clear? Okay, Maima, are you clear over here? We'll go with all the edge cases one by one. Just first let me know if you are clear. If you all guys are clear, I'm not asking specifically to her, I'm asking everyone. Yes, guys, please respond quickly. I can discuss later. Okay, that's fine. But everyone else is clear that okay, we might end up using sliding window. The window size might be variable, that is fixed, that is there. But there are two things. Okay, I'll reiterate it. Okay, there are two things, and that's why I tried to ask the same question with in the two different pattern. They said sum of find the maximum we need to calculate with the given size 3. So this was clear to you. So over here the size was fixed. This window kept on moving from here. So this window, I'm sorry guys, my window itself is moving. So this window kept on moving from here to here to here till, because the size was fixed in this particular question, right? But the next question, what it says, we are given sum fixed as 8. We need to find length. What length, what maximum length we can get. They can also ask for minimum length. They can also ask for minimum length. There is not an issue. You just need to tweak the logic according to question. Okay, so maximum length can be anything, or it can be -1 also if the sum is not present in the array, the sub array. So depends on whatever it is. So I'll omit this and we'll discuss the next part of it. How we'll discuss the edge case part of it. If so, just remember we were calculating, just to give you the brief idea. We were calculating max length for some 8, right? Over here it is 11. So if my start index and end index is they both are on the same position, and my length and my sum is greater than asked sum, my current sum is greater than asked sum, what we'll do is we'll move our start and end pointer to the next pointer if that next pointer is there in that particular question. So this is the edge case which we need to remember and tweak our logic accordingly. So what we did, so over here or we can also just we can, because our logic will fail over here, because our while loop will fail over here. So what we can do is that we'll just move this start and end pointer to here, and then again the same thing will carry on. 11 2 2 2 2, and suppose if I'm also adding 0 over here, that is also fine. Okay, so I'll teach you 0 part in the next class, because much of you will get confused with the logic. It's quite a thing to observe carefully. If you observe, everything looks similar, they are having different patterns. Guys, okay, so our start pointer, just 1 second guys. Hello, hello, just 1 second guys. Hello. Hello. Okay, got it. Hmm. Steve Jobs calls. Okay, not Steve Jobs calls, guys. Okay, so start and end pointer is now pointing to this element. So is 2 less than 8? Yes, we'll move the end pointer again. Is 4 less than 8? Yes, we'll move the end pointer again. Is 6 less than 8? We'll move the end pointer again. Is 8 less than 8, or is 8 is equals to required sum? Yes, it is equal to required sum. So what we can do is that we'll calculate e minus s plus 1, that is whatever it might be. It will give you 4. The length of 4 will be over here. and we'll compare the previous length. The previous length was saying 2. Somewhere the previous length I remember it was 2 only, because 5 and 3 was there. So we'll compare if max length is smaller than current length, we'll update the length and we'll be able to get 8 over here. Okay. Okay. I'll I'll make one more thing clear. Mm. Over here, if suppose if there was one more zero, what could we have done? Just think of it and let me know in the chat. No, Steve Jobs is calling me, Aniket. uh, can you let me know if there is one more zero? The length would now have become 5. Think over it and we you can calculate. Okay. So so uh, in order of n time you might have calculated in order of n time you might have calculated the best possible sum which you can calculate. The In order of n time you can do these both things, uh, these both variable, if the question is not asking for anything else. Okay. If you can run a window size of fixed window size and variable window size both in order of n time. If the question is asking something else, then we need to look onto it what it is asking and then act accordingly. I hope I am clear with sub-arraysum. Not sub-arraysum. I am clear with this sliding window, both the concepts where the window size is fixed and window size is variable. Let me know, guys, if I am clear. Guys, I am clear. I'll ping the homework maybe in the. So, what might be the homework for you guys? Uh, Homework for you guys will be to calculate. I'll ping you the homework, guys. I'll ping you the homework in the group, or maybe you can ping your email ID. I'll add the homework in the class of the Notion. Question more of kind two pointer and sliding window. Yes. Yes. Correct, Samkit. But I didn't wanted you to let you know that okay, it's a two pointer question. Yes, correct. But uh, okay, two pointer is not a question. It is not a pattern. I'll teach you two pointer. I'll come how we can go on two pointer. You are correct that it's the question more of a kind with a two pointer. Not so two pointer is a pattern where we can observe that okay, it's a basic logic only. We have just renamed it as two pointer. Okay. Are you guys clear with both the logics of fixed size window and variable size window? Is this both thing clear for you? I'll ping the questions in the group chat, and from there we can pick up a couple of questions, solve it, and then we can come to know that okay, what else we have learned, and whatever questions which you guys are not able to figure out within these days, these 2 or 3 days, maybe we'll have the next class on Tuesday only, because we'll always have class Tuesday, Thursday and Saturday, these 3 days only. So on next Tuesday in the night and Saturday on morning only. uh, so in the next Tuesday class, we'll solve the question which you guys might not be able to solve from the homework. We'll directly jump on to a code editor and I'll try to write the code. Meanwhile, I won't spoon feed you every single thing. My aim is not to spoon feed you every single thing. Just sit with the question, mug up, come with a solution, try something else, give some approach, come with some doubts that okay, these things are not working for me. I just taught you the best possible um, theory. Don't consider it as a question, guys. Don't consider it as a question. I just taught you some kind of theory. Questions will take up from tomorrow. Questions, I don't want to teach you guys questions, because questions are endless. Patterns are like we can organize. That's it. Maybe I will drop the I'll stop the stream, and we can go with the questions. One more thing, guys, please ping your email id so that I can add you in the Notion and install the Notion application wherever, and email and log in with that particular email id only. With that you will be able to see that okay, how many questions are there. Make one. अरे भाई, क्या लब बब्बर। भाई कहाँ है वो बंदा, मैं कहाँ हूँ, देखना एक बार। ठीक है, तो करते हैं ट्राई। ये इसको ये व्हाट सो वन मोर हम्बल रिक्वेस्ट, दिस क्वेश्चन 11 एंड क्वेश्चन 12 डोंट कंसिडर इट एज अ क्वेश्चन, ओके। इट्स जस्ट मोर ऑफ एन theory which I wanted you to explain, that okay, keep something like this in your mind and we can carry on, okay. Till then, see you on Tuesday's class. Please install Notion application, send your email ID so that I can add you in that particular Notion. Take a good care of yourself, solve much problems on it, because I think till the next three classes mostly we'll be solving the questions of sliding window only. Not three, at least two classes. Tuesday and Thursday we'll study sliding window, then we might move to either to carry forward. Yes, carry forward is also a technique. Okay, bye bye then.